So a relation is said to be function from set A to B if, see, what is the basic definition? If every element of set A has image in set B and only one image in set B. Okay. So what is the meaning of this thing? Okay. One second. I think this pen is not working. First I okay. So a relation is said to be function from set A to B if we have any set A and if we have any set of B. Okay. So what is the definition from relation to function? If function is defined from set A to B, if we have some element in set A like x1, x2, x3. Similarly, we have some element in set B, y1, y2, y3. So what is the definition? If every element of set A have at least one image in set B. A relation is said to be function if every element of set A has at least one image in set B and only one image. So what is the first condition? At least one image in set B is there. And what is the second condition? Only one image is there. Okay. So we have to satisfy at least two conditions for defining a function from set A to B. Okay. So what is the meaning of this term? It means if we have a mapping of A and B in this way, see, if we have mapping in this way, if we have three element and here we have two element, so what is the definition of every element of set A has image in set B? So here we have set A, here we have set B. So every element of, so if I connect one with two and two with three, then for three we don't have any image in set B. It means this mapping and this mapping is not a function because here for 3 we don't have any image. What is the second condition? If we have A and B, see here we have A and B, 1, 2, 3 is there, and I take A and B and C. Okay. So if I connect this one with 2, A and 2 to B and 3 also with the C. Okay. Now I take one more element. 4 is there, and this 4 is connected with B. Now it's a function because every element of set A has at least one image in set B, first condition. And what is the second condition? And only one image in set B. Okay. If I take the image of this one and connect with B, then here we have two images of this one in B. It means this is not a function. Also, this is not a function. Okay, one second. I think it disturbed the classes big. This pen is not working here. So give me 1 minute. So I can. Okay, give me 1 minute so I can doing the setting accordingly. Okay. It's not working. Okay. So let's see, if we have a function defined from set A to B, and here we have mapping in this way. A is connected with 1, 2 is connected with B, and C is connected with C, and 4 is connected with C. Now, can I say this is a function? Can I say this is a function or not?
Yes. No,
Why?
because the image have two images have the same pre-image.
Uh, but in function, only two things is required. See, what is the definition of function? If every element of set A has, see, if every element of set A has at least one image in B, this is the first condition. And second condition is and only one image in B. Okay, this is the condition for function. So if I define any function from set A to B, so condition is only for A, not for B. Okay, see, what is the definition? If function is defined from set A to B, then what is the condition? Every element of set A has at least one image in B. So what is the condition for set A? Every element of set A has image. It means here we have case 1. See, in this case, 1 and 2 has image in set B, but 3 does not have any image in B. It means this is not a function because 3 is not associated with any element here. Okay. What is the second condition? Here we have 1, 2, 3, 4 element, and every element has image in set B. Okay. It means first condition is already satisfied now. Then what is the second condition? And only one image in set B. First requirement is at least one image is there in set B, and second requirement is only one image is there. If more than one image is there, then this is again it's not a function. So here we have for one, this one has two image in set B. That's why this is not a function. Okay. So here nothing is given for set B. Only condition is imposed on set A. Okay. So we have to not seen in this condition in this way for set B. So here, see, what is the first condition? Every element of set A has at least one image. So here we have image for 1, also image of for 2, image for 3 is also there, and image for 4 is also there. Okay. Now check second condition. In second condition, if their element has two images, is any element is there in set A has two images in B or not? See, every element has only one image in set B. Okay. Because every element is connected with only one element. See, 3 is connected with only one element. 4 is also connected with only one element. 2 is also connected with only one element. 1 is also connected with one element. Okay. So this is a function. If we have case in this way, and here we have A, B, and C is there, and one is connected with A, as well as one is connected with B, then this is not a function, but this is a function. Okay. Now it's clear.
Yes, sir.
Okay. So for A, see, A is known as the A is the image of 1 and 1 is the pre-image of A. Okay, is this clear? So 1 is known as the image, sorry, A is known as the image of 1 and 1 is known as the pre-image. Okay, so similarly, B is known as the image of 2 and 2 is known as the pre-image of B. Okay, now we have one graphical definition of a function. Is this clear? If we have mapping in this way, so can I find the function or not? So this term is known as mapping. So one other definition. So function is also known as mapping from A to B. Okay. So here for today, pen is not working properly. So everyone please at least manage this thing. Okay. So here we have vertical test. See, if we have a graph of function in this way, if we have the graph of function in this way, so I want to check whether this graph is a function or not. Okay. So one test is there, which is vertical test. And what is the definition of this vertical test? If I draw a line which is parallel to x-axis, sorry, which is parallel to y-axis and it intersect the curve at more than one point, then the graph does not represent a function. Okay, is this clear? See, what is the definition? If we draw any vertical line, and vertical line is nothing but line which is parallel to y-axis. So if I draw a vertical line and it intersect the curve at more than one point, okay. So if intersect the curve at more than one point, then this is not a function. Why this is not a function? And this is a function. Okay, why this is a function? If I draw any vertical line, then it intersect the curve at one point. But here we have, in first case, here we have 2 points. So here see, this is the value of x here. And on vertical line, we consider that at every point value of x is same. So for this point I consider P, Q and R. So for P point, I can write x comma y1 and for this x comma y2 is there. So if I draw the mapping for x, see, x is connected with y1, also x is connected with y2 because x is connected with y1 and x is connected with y2. So here for only one variable, we have two images. That's why this type of graph is not considered as function. Okay, so in similar way, if we have a circle, if I draw a line, so see, two intersection point is there. It means this graph circle is not a function. Okay, is this clear to everyone? If I draw any line in this way, see, if I draw vertical line and it intersect the curve at only one point, then it is a function. One more thing is there. If I draw a graph in this way and only a small part is there, is curve part. So if I draw vertical line here, see, if I draw vertical line here, only one point is there. If I draw vertical line is there, 2 point is there. Okay. So this is not considered as a function. Okay. Why this is not a function? Because in mathematical statement, either statement is true or false. There is nothing like that, something which is smaller, little bit true and little bit false. Okay. So what I want to mean from here, if of one point is there at which I draw a vertical line and it intersect the curve at more than one point. See, if in this whole graph, I find one point where if I draw vertical line and it intersect the curve at more than one point, then this is not a function. Okay, so I only want to find one point where the function intersect the curve at more than one point. Is this definition is clear? So I draw one graph. Is this the function or not? Is this the function or not? Anyone? This graph will be function or not? Let's draw one more graph. Is this graph is function or not? Anyone tell me? Sir, only, sir, but only one or it connect. A connect more than one. Achilles, you have doubt. Okay. Sir, but one only it connect not. Okay. See, Achilles, you have a doubt here. So here one is connected with A and B. And also if I connect 2 with C, then here one has two images. That's why this is not a function. Okay. Is the vertical definition is clear to everyone? Simple definition. If I draw vertical line and it intersect the curve at more than one point, then this is not a function. Otherwise, it's a function of the graph. Okay. Sir, but only one only it can connect. Okay, sir. Okay. So now it's clear. So is this a function or not? Tell me yes or no. This is function or not? So this is a function because if you draw a vertical line anywhere, you get only one point. If you draw a vertical line, you get only one point. Okay. It means this is a function. Okay. But if I draw any graph in this way, and if I draw a line, then it intersect the curve at more than one point. It means this is not a function. Okay. Is this clear? So we have completed two definition of function. One is algebraic definition and mapping is there. And other one is vertical test, means geometrical definition is there. Achilles, please on your audio and can you repeat this again? Please on your audio and ask me the question. What is your question here? Achilles.
Sir, can you explain this concept? I have
Which one? Vertical test method or above one?
yes, sir. Yes, sir. Yes, sir.
Vertical test method?
Yes, sir.
See, vertical test method is just belong from here. Here we know that in the definition of function, here we know that every element, see here every element has at least one image in B, okay, and only one image in B. This is the definition of function. Okay, why this is the definition of function? Because function is belong to the real world. Let's take one example from the real world. See, here we have one fan. Okay, and regulator is there. Okay, how many numbers is there in the regulator? How many number is there? See, everyone is familiar with the regulator of your fan, your home fan. Okay. See, here we have the number 0, 1, 2, 3, 4, and 5 is there. Is this clear to everyone? Okay. See, here we have some number 0, 1, 2, 3, 4, and 5 is there. And here is the speed of your fan. Okay. So what is the function? Here, speed of fan is the function. So if I take the value of 0, it means fan is stopped. If speed is 1, then some speed, sorry, 1 is there in regulator, then some speed is there, let's say S1. And for S2, we have some speed. For S3, we have some other speed. For S4, we have some other speed. And also for S5, we have some other speed. Is this clear? This is the example for function. Okay. So everything you see around your around your word, everything is the function. Why this is a function? Because for every element of set A, we have some associate image in set B. Is this clear? Let's say you buy one fan and in the regulator, you find some more number. Let's say 6, 7, 8 is there. Okay. And for 6, 7, 8, here, fan is not working. Okay. So if you put the regulator at 6, then fan is not working. And 7, fan is also not working. For 8, fan is not working. Okay. So can I say this fan is completely working? Or not? See, if you have regulator and you have number from 0 to 5 is there, and you write anybody, you write 6, 7, 8 is there, and one person make this regulator on the mark 6 and check that, but fan is not working. So if this number is there on the regulator, then for this number, fan must be response anything about accordingly this number. Okay. If fan is not respond for this number, it means this fan is considered as not working. Okay. So in function, we said that not a function. Similarly, if you have a mobile and here we have some number 0, 1, 2, 3, 4, 5, up to 9 number is there in the mobile. If some key is also there, whose number is 10, 11, 12, but you find that for 10, 11, 12, mobile is not responding, then what I have to say about this function? I consider that this mobile is not properly functioned. Okay. This is the example from your real world. Okay. So lots of things is there in your around you, which is a function. Okay. So here function is nothing but a real definition in real world. Okay. So let's see one more thing here. See, for 0, we have only one condition of the function, stop is there. So for 1, we have some speed S1. Okay. Let's suppose if you set the regulator at 1 and function speed is fan speed is S1, and suddenly fan speed is become S2, and suddenly fan speed become S3, and again then S1, then what you will consider? Is this possible in real world? You set the regulator at 1 and speed of the fan is at let's consider S1 speed, then it increase, then it decrease, then increase for the same regulator. Is this possible in real world?
No, sir.
Okay. That's why we consider the function that for here, if we have only one element, then we have only one associated relation is there. See, here for 1, we have only one associated relation here. If we have more than one relation, then this is not a real world example. That's why I've not considered this thing is a function. Okay. Now it's clear. Now
Okay, sir.
okay. So let's see the graph. If I draw any graph, so here I consider that function is defined from x to y. Okay, so x is here and y is here. And if I draw a vertical line, so here one point is there, x is also there. See, in whole this vertical line, x is always remain constant, but only y is changing. So for this point, x is associated with some y. Also for this point, x is associated with some y too. So if x is there, and here we have 2.y1, so this x is associated with y1. Also this x is associated with y2 because 2 point is there. Okay, here we have 2 points. So this type of example is not a function, we already know. Okay, that's why vertical definition say about these things. If we draw any vertical line and it intersect the curve at more than 1 point, it means 2 point is there, 3 point will be there, 4 point will be there, then this graph will not a function. Is this clear now, Akhilesh?
Sir, then the parabola does not intersect, sir.
Yeah.
So how it may be function, sir?
See, this is not a function. There are two types of parabola. This parabola is not a function, but this parabola is a
Sir,
function.
that second parabola, sir.
Okay, let me take one example. See, here we have y square. Sorry, this is the example of x square equal to 4y types of graph. And this is the example for y square equal to 4 of x type of graph. Okay, so here we have two types of example. Okay, in second example, see, if I take the value of y is 4, okay, so x square become of 16. From here, we have two value of x. One is plus minus 4. So now I draw the mapping of this value. Here we have one value of x. Here we have another value of x. And what is the value of y? Y is 4. Now connect this value with 4. And now connect this value is 4. Is this a function or not? Achilles, is this a function or not?
Sir, function, sir.
Yes. Why function? Because if I consider this element, then this element is connected only one element. 4 is there. If I consider this element and this element is also connected with only one element, 4 is there. Okay. So this is considered as a function. See, one example is there. In real life example, let's see if the regulator of fan is not working. Then if you rotate the regulator again and again, then speed of fan is 6. Is this clear? Okay. Is this the example of a function? Okay. Now take one another example. If the brake of car will fail, then can I consider the speed of car will be same for some time? If I ignore the friction, can I say that if brake of the car will be fail, then the speed of the car remains same? Okay, so this is one of the example for constant function. This is the example for constant function. So here, whatever be the value of x is there, only one value of y is there. So this is the example of constant function. Okay, if you take value of is 1, 2, 3, 4, then you get only one value of y. See, is this clear? Now it's clear, Achilles.
Yes, sir.
So we move forward. Okay. So now we already know about the definition of vertical test method, and other one is what is the definition of function is there. Okay. Now we have one term which is domain of the function. So today we are focusing on this concept. What is the domain of the function? Okay. So if I define from mapping, see here we have a mapping. A is there and B is there. Okay. And one function is defined from here to here. Okay. So if I take 1 and 2 and 3 element is there. So for every element of set A, some image will be there in B. It means for this element, function will be defined. And this set A is known as the domain of this function. Okay. So this A is known as the domain of this function. And other definition is, if a function is defined from x to y, if we have function in term of x, okay, if a function is defined from x to y is there, and I can write this definition in this way: x square equal to something, y is there. So if function is defined from x to y, then this x is considered as domain. Okay. And what is the definition? Other definition: values of x for which function is defined. Value of x for which function is defined. So collection of all the values of x for which this function is defined is known as domain. Okay. Known as domain. So I have to take the set or collection of all values of this x. Okay. So now I'm adding collection of values of x for which function is defined. What does mean by the function is defined? Let's see. If we have a definition in this way, fx equal to root over x minus of 1 is there. So if I say that function is defined, it means function is defined in real world. Okay. Function is defined is real world. I'm not consider any point which lie in imaginary or complex number. So this function must have real number as value. Okay. That's why we call this function as real valued function. Okay. So what is the definition of domain of the function? Collection of values of x for which the function is defined is known as the domain of this function. So here we have first condition. See, if we have fx equal to some root function is there. So if I take any value of x like that, see, if I take the value of x is minus of 2, then this whole expression become minus of 3. It means inside the root we have negative number, and this negative number is a imaginary number, or this is a complex number. Is this clear to everyone? But here I want value of x is real only. That's why I cannot consider this value in a domain of this function. Okay. So when this function, when this x will be the domain of this function, when x minus of 1 is either equal to 0 or positive. Okay. So from here we have one condition from the domain. If we have anything which lie inside the root, then root will be positive. Okay. See, if we have, what is the first rule? If we have anything inside the root, then this fx must be greater than equal to 0. Okay, this is the first rule. Similarly, if we have anything in this way, see, if we have in the denominator 0, then this term will be undefined. Okay. So I cannot take any point which lie in the denominator. See, if x minus 1 is there, so if I take the value of x is 1, then this whole term will be not defined. So I cannot take the value of this x is 1. But apart from 1, I can take any value of this x. So it means the domain of this function is real number minus of 1 is there. Okay. Is this two rule will be cleared? Is this clear to everyone? Rule 1 and rule 2. If you have anything inside the root, then you have to take this term must be greater than equal to 0. Okay. So from here, I can write x is greater than equal to 1. It means for this function, domain will be nothing but x is greater than equal to 0. So x will be, domain will be 1 to infinity. Is this two rule is clear or not? Third rule will be, if anything in log and see x is there, so for this x must be greater than 0. And if x is lie at the base, here we have the x. So for this x must be positive, and this x cannot be equal to 1. If this will be 1, then I get log of a divided by log of x. And if this 1 is there, so I know that log of 1 equal to 0. It means again here we have some 0 is there. That's why this whole expression will not define again. That's why if x is there in the base, then I considered this definition, x is greater than 0 and x is not equal to 1. Okay. Now rule 4 is there. If we have any inverse function, see, if we have, I know about, familiar about this function, sin x is there. So for this sin x and cos of x, if this function is there, then this function is always defined. Similarly, if we have any polynomial function is there, let's suppose linear function is there, quadratic is there, cubic is there. So for every polynomial function, function is always defined. Okay. So if you have any function which is polynomial, let's suppose, see, x plus 1 is a linear function, ax square plus of bx square plus c is a quadratic function, and so on. We have lots of polynomial function is there. So linear function, all polynomial function is always defined. Sine function and cos function is also always defined. One more rule is there. See, if you have any function in this way, or cos inverse of x is there, so for this x, one boundation is there, this x must be lie between -1 to 1. Okay, so here we have 5 rule, and by using this basic rule, I can calculate the domain of the function. Okay, so, is this clear to everyone? What is the first rule? If you have anything inside the root, then take this fx is greater than equal to 0 and find the value of x. Okay. If you have anything inside in the denominator, then this term cannot be equal to 0. Okay. If you have any term in log, then this x will be greater than 0. If you have x in the base of log, then x is greater than 0. Also, x cannot be equal to 1. If you have any function in sine and cos, then this is always defined. Always defined means its domain is a real number. You can take any number from here. Similarly, polynomial function is always defined. It means the domain of the polynomial function is also real number. And if you have any term in sine and cos, then this x must be lie between -1 to 1. Is this clear to everyone? So we are going to solve the questions. Achilles, is this clear? Bhavna?
Yes, sir. Clear, sir.
Okay. So we are going to solve some question from domain section. See, here we have first question from the domain. What is the question? The domain of the function fx equal to root over something and divided by x square minus of 9 is there. Okay. So here we have two terms, one term inside the root. So what is the condition for this term? can I say x plus of 2 must be greater than equal to 0? Is this correct?
Yes, sir.
Yes, sir.
So x must be greater than equal to minus of 2 is there. Okay. If I draw this condition in real number line, so here we have minus of 2 is there, and I can take the value of x is minus 2 also, and any number which is greater than this minus of 2. So minus 2 is included, and I can take any number which is greater than minus of 2. So from here, the value of x is from minus 2 to infinity. Okay. Now, if I see this term, so this term is in the denominator, and for this term, I can say that x square minus 9 cannot be equal to 0. If this become a 0, then this will be not defined. Is this clear? So from here, we have two term. One is x minus of 3, other one is x plus of 3. If I going to use the a square minus b square formula, so from here I can say that x cannot be equal to minus 3 and x cannot be equal to 3. Okay, is this clear to everyone? So from here, one point is minus of 3. I cannot take this value. Also 3 is there. I cannot take this value. Apart from this 2 value, I can take any values of x for this denominator part. Okay. So for second, this part, what is the domain? I can take any number from here to here and from here to here. Okay. So if I want to find the domain of this function, then I have to take the common value from this two condition. So here we have one condition, here we have another condition. So if I take the common condition, then draw a vertical line. See, if I draw a vertical line and try to find the region in which two lines is there. If we have two condition, then find the line where two condition is there. So here we have one line and here we have also one line. But if I take any number which is less than minus 2, so only one line is there. It means one condition is satisfied, other condition is not satisfied here. Okay. So what is the common condition from these two? I can take the value of x from minus of 2 and I included this value to 3 and union of 3 to infinity. So this is the answer of this question. So here we have some value. C option is there, which is the domain of this function. Is this clear to everyone? Okay. So now we are going to find the domain of this second function. Here we have some function inside the root. So what is the first condition? If anything lie inside the root, then what is the first condition? This whole expression is greater than 0. Is this correct? And equal to 0. Okay. So if we have anything inside the root, then this whole expression must be greater than equal to 0. This is the first rule. Okay. Is this clear to everyone? So now we are going to use the Wavy curve method. Before going to use the Wavy curve method, first make the coefficient of x is positive. Okay. So first make the coefficient of x is positive. Here x is positive, but here we have coefficient of x is negative. Also here we have positive, here we have positive. So only one is term is there which is negative. So first step is for Wavy curve method is first make the coefficient of x is positive. So what I have to do? Just multiply this term with minus sign or take minus sign common from here. If you multiply this whole expression with minus sign, then the inequality will change. So x minus 1 is there. And here I get, if I multiply with minus sign, then I get x minus 7. And here we have x and x minus of 5 is there. Okay. So this expression will now become less than 0. Now this is the first step. Make the coefficient of x is positive. Now find the critical point. What is the critical point? Just make this term equal to 0, this term equal to 0, this term equal to 0, this term will be 0. If I make this term equal to 0, see, now from here I get 1 point, 1 is there, and one critical point is 0 is there, and here we have 5, and here we have 7. Okay, so here we have 4 critical point, and critical point is nothing but just make the factors equal to 0, and you will find some point, and arrange this point on the real number line. Okay, now rightmost part is always positive. Now I want to see the power of this term. If the power of this factor is odd, then sign around 7 will change. If the power of this term is even, then the sign remains same. If the power of this factor is odd, then again sign will be changed. See, also power of this x is 1, so sign will be changed. Is this clear to everyone? Okay. Now, one more thing is there. We have some terms in the denominator. So for this term, I cannot take the value of this x equal to 0 and 5. Okay, it means at 5 we have open circle. I cannot take this value. Also at 0 we have open circle. Okay, so now by using the concept of Wavy curve method, I can say this: if anything which is greater than 0, see, anything which is greater than 0, then this whole expression is positive. So I have to take the value of x from this real number line where positive reason is there. Okay, so only two reason is there where positive sign is there. So x is nothing but from 0, open interval 0 to 1, union 7 to infinity is there. This is the answer of this question domain. Okay, now let's see what is the if domain of fx. Sorry. I have to take the negative sign. Why negative sign is there? Because in final expression, you will find that minus this whole expression. In final expression, this whole expression become less than 0. So here we have this reason and this reason and this reason. Okay. Now what is the question? If domain of fx is d, then number of positive integer in D will be. So here we have negative numbers. So I cannot consider this for domain. So from 1 to 3, see, I can take the value of 1. So 1 is there, then 2 is there, 3 is there, 4 is there, but I cannot take 5. So again we have 6 is there, also 7 is there. So how many points are there which is positive and satisfy the domain of this function? So here we have 6 number. So 6 is the right answer. Are you familiar with the Wavy curve method, everyone? Because Wavy curve method will be taught in, has already been taught in 11th class. Are you familiar with this concept?
Yes, sir.
Okay. So now we are going to take one more example. Let's see. The domain of the function fx equal to root over sin x and root over x minus 2 and 8 minus of x. I am now only studying in 11th. Okay, so Akhilesh, I'm going to explain everything from the basic, but some concept will be from 12th. Okay, so maybe it may be possible that you will not understand some things. Okay, then you will ask anything in the last of the class. Okay, at the end of the class. See, here we have what is the basic rule? We have 5 rule. Sine function is always defined. Cos function is always defined. Okay, and if we have anything inside root, then function is must be positive. So here we have two terms. One is this and one is this. Okay. So for this term, I can say that, see, this sin x is lie inside this root. It means this sin x is greater than equal to 0. Is this correct? Now we are going to solve the question. So you can enable your audio. Okay, just unmute your audio. If background noise is not there, then you can answer. Okay, so sin x is there. See, sin x is there, and sin x must be greater than equal to 0. Okay, are you familiar with the graph of sin x, everyone?
Yes, sir.
Okay, now I am going to draw the graph of sin x. See, this is the graph of sin x. Here we have 0. Here we have pi. Here we have 2 pi is there. Okay. Now in all the options, you will see that only 2 pi is there. Also 8 is there. Okay. So let's take one more point, 3 pi. See, this is nothing but 3.14 is there. Here we have 6.28 and here we have 9.42. Okay. Is this clear? See, can I say that from 0 to pi, sin x is positive? So here sin x is positive. From pi to 2 pi, sin x is negative. And 2 pi to 3 pi, sin x is positive. Okay? Everyone, is this clear?
Yes,
Now,
sir.
I can explain this by quadrant method. In first quadrant, 0 to pi by 2, all functions are positive. So sin x is also positive. Similarly, from pi by 2 to pi, sin x is positive here. So from here to here, sin x is positive. But pi to 2 pi, sin x will be negative. So I cannot take this reason. Again, from 2 pi to 3 pi, sin x will be positive. So here we have two reason where sin x is positive. Okay. So from here, I can, for sin x only, I can write that x belong to closed interval 0 to pi union pi 2 pi to 3 pi. Okay. Because answer is up to 2 pi, 8 pi is there. That's why I'm taking this value. If more value is there, then I have to take the value in this way. See, 4 pi to again from 5 pi. Why this value? Here 0 is there. Then from 2 pi start. Then again, if I move from here, then we have 4 pi is there. See. Also, you can see from here. See, from here I start and here I end. So here we have even pi and here we have odd pi. So from 0 to pi, 2 pi to 4 pi, 2 pi to 3 pi, and from 4 pi to 5 pi. Similarly, 6 pi to 7 pi. This is all the solution of this sin x is greater than equal to 0. Okay. Now, what's about this condition for root x minus of 2 and 8 minus of x is there, and this term must be greater than equal to 0 because this values lie inside the root. But I cannot take equal to sign is because this term again lie inside, is lie in the denominator. Okay. Is this clear to everyone? I cannot take equal to sign. Root is there for root only. If I consider the condition, then this whole expression is greater than equal to 0. But this term is lie in denominator. That's why I cannot consider equal to sign. It means I cannot consider equal to sign. Then from here, I have only greater than sign is there. Okay. Now, if I want to use the Wavy curve method, then first step is to make the coefficient of x is positive. So for this, I have to multiply this term with minus sign. And if I multiply this term with minus sign, then inequality will reverse. Again, we have two critical point. 2 is there, 8 is there. Take plus sign, minus sign and plus sign. Okay. Now, which region I have to consider from here? Tell me which region I have to consider from here. Sabik, are you familiar with the Wavy method or not? Akhilesh, Bhavna, Sabik, Sri Vignesh. Anyone tell me about which reason I have to take from here? See, here this whole term is negative. Okay, just take one point from here. You will find the answer. If I take any number from here, see 9 is there. If I take 9 here, then 9 minus 2 is there and 9 minus of 8 is there. Then this term will be positive. Also, this term is positive. So here we have positive sign. So positive number is less than 0. This is wrong. So I cannot take this reason. Again, if I take any point from here, then this whole expression become positive, and positive expression is less than 0. See, this condition is wrong. So I cannot take this condition. So if any expression is less than 0, then you have to take negative sign in Wavy method. If this expression is greater than 0, then you have to take greater than 0 sign. Okay, and where greater than 0 sign is nothing but positive reason. So here we have two terms. One is there and here one condition is there. So from this condition, we have this type of solution. And for this condition, we have this solution. Okay. So if I make the common from these two solutions, so from first solution, we have 0 to pi is the solution. Also 2 pi to 3 pi is the solution. Okay. Now I have to mark this 2 point in this region. So here 2 is there and 8 is lie in between of them. Okay. Now what is the solution? One solution is from 2 to 8. Other solution is from 0 to pi and 2 pi to 3 pi. Okay. Now take the common reason. What is the common reason? Tell me what is the common reason from here? See, where 2 line is there, the reason will be common. So 2 to pi, 2 to pi is there and 2 pi to 8 is there. So this is the right condition. Is this clear to everyone? Sir, I think A. No, B is the option. Please. Okay. Now, one more question is there in log. Okay. Are you familiar with the log or not? If you're familiar, then I will solve this question. Otherwise, not. Anyone? Bhavna? So, please respond, everyone.
I am familiar, sir.
Okay. Just just type yes if you're familiar. Achilles and yes. Yes. Okay. So if you are familiar with the log, then I can solve this question. Okay. See, so this whole term inside the root, it means first step is log of 2, 1 by log of x base 2. This term will be greater than equal to 0. Is this correct? Okay. Now just remove this log. How I can remove this log? If x is there, a is there, and this term is equal to y, then if I replace this log, then this x is equal to base raised to the power y. Okay. If I replace this log, if I remove this log from here, then this x become a raised to the power y. So here we have y in the right hand side. Similarly, here we have 0 is there, and here we have 2 is there. One more concept is there. If we have any number which is less than 1, then this inequality will be reversed if I remove this log. Okay, so from here I write, if I remove this log, then I get log of x base 2, only this term, and inequality remains same. And here we have base raised to the power this right hand side. See, here we have base and base raised to the power this y. Okay, and this is nothing but 1 is there. Okay, so from here we have 1 by log of x base of 2, which is greater than equal to 1. Is this clear to everyone? Okay. Now I can write this term. See, I can write this term in this way. By using the property of log, I can write this term in this way. Okay. Also, if I take minus sign here, so from here 2 is there, x is there, and I considered this one is nothing but log of x base x. So by using the property of log, this whole term is greater than 0. Okay. Now let's see when log is greater than 0. So from here we have two conditions. Either this x is greater than 1 or this x is lie between 0 to 1, because this x is the base, and for base we have the condition x is greater than 0 and x is not equal to 1. If x is not equal to 1, then I convert this reason into two parts. One is x greater than 1, other one is x lie between 0 to 1. Okay. Now if I remove this log, so from here I get 2 by x, and if number is greater than 1, then inequality remains same. And if this x is lie between 0 to 1, then inequality will remain reverse, and this term I will get. So from here 2 by x is greater than equal to 1. So from here 2 by x minus 1 is the solution. So from here 2 by x is there. So just make the coefficient of x is positive. So 0 is here, 2 is here. Take the plus minus plus reason. See, from here you find the reason in which this expression is less than equal to 0 is 0 to 2 is. 0 to 2 is the solution. But here I consider that x is greater than 0. So if I apply the condition here, x is greater than 1, then from here I find the solution from 1 to 2, where I can include this term, but I cannot include 1. Similarly, if I solve this term, 2 by x is there, minus of 1 is there. So from here, 2 minus of x by x is there, less than equal to 0. Just make the coefficient of x is positive. So multiply this term with minus sign. And from here, you find 0 and 2. And plus sign is there, minus sign is there, plus sign is there. So one reason is this one and other reason is this one. But here we have x is lie between 0 to 1. So in 0 to 1, we don't have any solution. So this condition is not satisfied. This condition is satisfied. From here I get this term as a solution. Okay. So in log you have to do multiple steps for finding the solution. Is this clear to everyone? Okay, so let's see. One condition is here I am calculating only one condition. So this term, whole term will be inside the root. That's why I am solving this term. And what is the second condition? See, this whole term is considered as x for this log. So 1 divided by x base 2 must be greater than 0 because this is the x for this log, So if this term is greater than 0, then again I have the condition x is there and 2 is there. And here this x is greater than 0 and this whole term is greater than 0. Okay, I can write this term. And from here, what is the condition of x? If this term, whole term is greater than 0. So what is the one condition? If this x is greater than 1, then this expression will be positive for this type of graph. So from here, you can write 2 is greater than x raised to the power 0. And see, from here, I find nothing but 1 is there. So this condition is satisfied. And if I take x is lie between 0 to 1. So from here, I have this condition, which is wrong. So in 0 to 1, I cannot find any solution. And if x is greater than 1, so I find some solution. So that's why x is greater than 1. So where we find the condition, x is greater than 1 and from 1 to 2. So this is the solution. Okay. So in domain, you have to find multiple steps because root is there, log is there. So I have to apply the condition for root first. Then I have to apply the condition of log. So if you are familiar with the log terms, then you can solve the question of domain from the log portion. If you are not familiar with the log, then please ignore this question. Okay. So are you familiar with all these things? Everyone? Now we are going to take some questions from the PYQ. Okay. So let's take this question. This is a question from 2024 JEE Mains. So what is the question? If the domain of this fx function is real number minus a and b, alpha and beta, then what is the value of 12 times of alpha and beta? Okay. So what is the condition? If we have any term in sine inverse x, then what is the condition for this x? Is this x lie between -1 to 1 or not? Okay. See, so for this sine inverse of x, this whole term is considered as x. So this term x minus of 1 by 2x plus of 3 must be lie between -1 to 1. Can you solve this type of inequality? Anyone? So for solving this type of inequality, I have to solve one by one. First one and after this one. Okay. So if I solve this right hand side inequality, so here we have x minus 1 is there, 2x plus 3 is there. Subtract -1 from here. Okay. Now take x minus 1 is there, 2x minus of 3 is there, and from here we have 2x plus of 3, and this whole expression is less than 0. Okay. Now if I subtract 2x from x, then I get minus of x, and here we have minus of 4. Here we have 2x plus of 3. Again, for if I want to apply the Wavy curve method, then make the coefficient of x is positive. Okay. So multiply this whole term with minus sign. So if I multiply this term with minus sign, then I get x plus 4 and 2x plus of 3. Okay. So and change the sign of inequality. So from here we have 2.1 is -4, other one is -3 by 2 is there. Okay. So plus sign is there, minus sign is there, then plus sign is there, beta. So which reason I have to consider? Because this term, see, this whole term is greater than 0. So I have to take positive reason. So one reason is this one, another this, and other is this one. Okay. So this is the solution for this inequality, right hand side inequality. Okay. For left hand side inequality, take this term x minus 1 and 2x plus of 3. And see, here if you multiply this term, cross multiply this term, then you will get the wrong answer. Okay. So never try to multiply this term, denominator term, 2 minus 1. Okay. Every time if you want to solve this question, take all the term on the right hand side. Why this? Because if you multiply this term with this minus 1 and you remain this inequality same, then you will get the wrong answer. Why? Because you consider this expression is always positive. Let's see the condition. If we have number in this way, see, 1 by 2 is there and 1 by 3 is there. So this condition is absolutely right. Nothing is wrong here. But if we have number in this way, see, minus of 3 is there, and here we have minus 1 by 2. Okay. I can write this number in this way. 1 divided by minus of 2. Is this correct? Is this correct or not? So if this correct, then if I multiply this term, cross multiply this term, then here we have 6. And if I not change the sign of this inequality, then I will get the wrong answer. So just avoid, if you multiply this term here, then you will get the wrong answer if denominator will be negative. Okay. So if this term, see here, you don't know the sign of this x. Okay. If you don't know the sign of x, then never multiply this term in cross multiply. So what is the method to solve this? Just take this one from left hand side to right hand side. So here I get x minus of 1, and from here 2x plus 3 is there. Okay. So 1 is there. So if I take the simplify, just take simplify this term. So x minus 1 is there and 2x plus 3 is there. And again here we have 2x plus of 3. Now from here 3x is there, 2 is there, and 2x plus of 3 is there, and this whole term is greater than equal to 0. Okay. So from here, now again I am going to use the Wavy curve method. So here we have 2 points. One is minus 3 by 2 and other one is 2 by 3. So this is one term, other one is 2 by 3. Write the plus minus plus reason, and if this expression is greater than 0, so you have to take one this reason and positive reason from these two. Okay. So from here, if I take any value of x, then this x must satisfy this inequality and simultaneously this inequality also. Okay. It means I have to take the common between these two conditions. Okay. If I take the x from these two, which is common, then this is considered as the domain of this function. Okay. So here we have one line where minus 3 by 2 is there and minus 2 by 3 is there. And here I have take the solution. See, this reason and this reason is the solution of second one. And what is the solution of first one? Minus 3 by 2 to infinity. One solution is there, and from minus 4 to minus infinity, other solution is there. Okay. Now it's clear to everyone. See, from these two, I have to take the reason which is common. So from here, minus 2 to 3 to infinity, you can take any number. Okay. Is this clear to everyone? And from here, minus infinity to minus of 4, you can take any number. Is this clear? Is this clear or not? Okay. Now, what is this alpha and beta from here? See, what is this alpha and beta from here? So can I say from here what term I have not to take from here? See, this condition. So I cannot take any number between this reason. Okay. Is this correct? I cannot take any number between this reason. Minus 4 to minus 3 by 2. Okay. So this is a interval. So alpha is nothing but minus 4 and beta is nothing but minus 2 by 3 is there. Okay. Because this, if I take any value between this reason, then the condition will not satisfy. Also, here also we have only one line is there. So here also we have condition is not satisfied. It means beta is minus 2 by 3. So in between this reason, if I take any point, then condition will not satisfy. That's why this value is excluded from real number. So alpha is nothing but minus of 4 and beta is nothing but minus 2 by 3. Then now what is the condition? 12 times of minus of 4 multiply minus 2 by 3. If I multiply here and if I multiply minus sign, then it will be positive. And 4 multiply 4 is 16 multiply 2, which is 32. It means answer of this question is 32. Is this clear to everyone? Okay, now take one more example. Here we have, let's take this question for your homework.
Session available in recorded class, sir.
Sorry, Achilles?
Sir, is this session available in recorded session?
Yeah. This whole session will be recorded. I will share the link of this after this class. Okay?
Okay.
So you
Okay.
can see this video again and again. And if you have any doubt, then you can ask in your next lecture. Okay?
Okay, sir.
Okay. So I am going to give you some questions after this question. See, here we have one term. Cos is there. So what about this term? Can I write 2 minus modulus of x by 4, which lie between minus of 1 to 1? Is this clear for this cos? Because inverse is there, that's why this x must be lie between minus 1 to 1. And if this term log is there, so this is nothing but 1 by log of 3 minus of x is there. And for this value, see, 3 minus of x must be greater than 0. And if this term is lie in the denominator, it means this term cannot be equal to 0. Okay? If this term cannot be equal to 0, when log will be 0? When log will be 0? When log 1 is there. Okay? So log 1, value of log 1 is 0. So if I solve this, so 2 is x is there. So I cannot take the value of this term equal to 1 because log 1 is in the denominator and log 1 is 0 here. Then this term will not define. So from here, 1 x cannot be equal to 2. From here, I can write that x is less than 3. Okay. So from log part, we get number which is less than 3 but cannot take 2. Okay. So we are going to solve this term. And what about this term? Here we have positive sign. See, if we have positive sign in the denominator, then you can multiply this term here. So if I multiply this whole inequality with 4, then inequality will not change. So from here I get -4. And from here I get 4. Then take this to here, then here we get -6. Then minus of modulus is there. And here we have 2. Okay. Then multiply this whole expression with minus sign. Okay. Now I get one condition from here. This modulus is less than 6 and greater than -2. See, this is a positive number. So this condition is always obvious because positive number is always greater than negative number. So I have to consider only one condition. This x is less than -6. So from here, if you know about little bit about the modulus, then you will know about this solution. X is lie between -6 to 6. So from here, one solution is there. From here, another solution is here. So I have to take common from these two values, -6 to 6, and 2 and 3 is also here. So I can take any value from first condition. I can take any value from 3 to -infinity, but I cannot take 2 from here. So just find the line which is common between of them. See, so I can take the solution from -6 to 3, but I cannot take 2 as a solution. Okay, now let's see what is the question here. Here we have some number which is solution and gamma is not there. So from here, let's see. See, alpha is nothing but 6, but also I cannot take 3. That's why here we have open bracket. So alpha is nothing but 6, and in place of beta we have 3. And in place of gamma we have 2. See here, we have 2. So I know the value of alpha, beta, gamma. So can I add all these terms? Because alpha, beta, gamma value is there. So if I add 6 plus 3, then 9 is there. If I add 9 with 2, then 11 is there. It means what is the solution? 11 is there. See, this is the question from your JEE Mains 2024. Is this clear to everyone? Okay. So if you have any doubt, then try to solve these basic questions and ask me in our next lecture. Okay. See, again, here we have cos inverse term is there. It means 2x minus of 1 by x plus of 2 must be lie between -1 to 1. And for this condition, log base, see, this is the x of log. It means this whole expression is greater than 0. Can I solve this type of condition by using the Wavy curve method? Also here we have term. See, here in denominator, you cannot predict the sign of this whole expression. That's why from here you have to make two cases. One is 2x minus 1 by x plus 2, which is less than equal to 1. And another one is 2x minus of 1 by x plus of 2. So solve this condition and this condition, and definitely from here you will find some domain, and from here also you will find subdomain, and you have to take the common from this. Can you solve this question? Okay, so I give this question in your homework. So we will discuss this question again in your next lecture. Okay, everyone. So,
Sir, very good, very good.
so now we are going to end this session. So Bala sir, if you want to say anything of this class and if you share any news to the student, then please sir.
Yes, sir. Few new students came, and see, total including you and me, 12 members at the beginning, 12, and then end of the class, only 2 members are there.
Okay,
Oh, I
this
am.
class is actually this class will be more than 1 hours. Maybe all this concept is new from lots of students. So I considered all these students know little bit about the log and modulus is there. If I want to cover all these things, then the class will be lengthy. So let's see, just
Okay.
talk with the student and take
Okay.
feedback accordingly. If they don't know about all these things, log, cos inverse of and modulus of things, then I have to start from the all basic things because I
Okay.
already
Okay.
start all these things from the basics, sir.
Okay, sir. Okay.
So if they are the student of 12th class, it means I assume that they know about the log, they know about the basic of modulus function, and also they are familiar with this Wavy curve method. So in this whole
Okay. Okay.
lecture, we are going to solve this Wavy curve method and log portion. Only inequality is there. Oh, okay. So also you can suggest the student they can see the lecture of 11th class because in 11th
Yeah.
class I will explain the Wavy curve method. Okay. So if
Okay.
they will see the lecture, then they will consider they can easily understand all these things. Okay, sir.
Okay. Okay.
Okay, sir.
Okay. Thank you, sir. Thank you. I call you, and we want to retrain the children from beginning to end. That is the very important thing in our session.
No
See, they are
problem.
all coming and going.
Okay. So see, this is the I think this is one of the second class of the 12th, and first I have to know the what is the level of this all student.
Yes, sir. Yes, sir. Yeah.
So if I know the student level, then I manage my classes accordingly.
Okay. Okay.
Okay, sir.
Okay, thank you. Thank you, children. Only 2 students are here. Galaxy M01 core, may I know your name? Hello? Galaxy M01 core. I think today only you are attending.
Sir, my name is
Actually,
Jishnu.
your name?
Jishnu, sir.
Jishnu. 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 Okay, okay, Jishnu. Okay, okay. Okay, Akhilesh and Jishnu, I would like to say the SARS recorded session. Okay, you can see. You keep watch 2-3 times, then only you will get some understand. Okay, so don't
Okay,
miss
sir.
the class. Akhilesh, thank you. Jishnu, thank you.
Thank you, sir. Thank you.
Okay, sir.
Thank you so much, everyone. Good night.
Thank you, sir. Good night.
Thank you, sir. Good night. Yeah, yeah. Good night. Good night.